Okay, we're given number 6, a 2,500-pound car, 10-degree banked 300-foot radius curve, given a constant speed of 90 feet per second, and we want to determine the magnitude of friction force and state where it's up or down the bank. Assume the car is not sliding, and we're given a mu sub s. So magnitude of friction force, curve, bank, track. Oh, this is a fun one. Just a note for those watching it in spring 2013, this was a normal acceleration as part of this one. We have not covered that yet. We changed topics about a year ago, so this would not be on a 2013 test, but we'll go ahead and work it here. Oh my, so let's draw head-on view. Let's see, head-on view. Here's my track. So 10-degree bank. Okay, here's my, sometimes it helps to draw a little bit of detail. Okay, to show that we're coming head on. Not much of a car. Okay, a couple keys here. We know it's a 300-foot radius curve. So that's a horizontal distance. And we know we're going at a constant velocity, so I'll make a note of that, 90 feet per second. And constant velocity means my tangential acceleration is 0, so there's a key point. So the only acceleration is going to be a normal acceleration. So let's go ahead and draw kinetic diagram. Oh, pretty rough. Okay, so my normal acceleration is going to be pointing towards the inside of the curve, a sub n. And I can calculate that. I know my velocity. Normal acceleration is v squared over r. I know my velocity, 90 feet per second. And I know the radius, 300 feet. Okay. 90 squared divided by 300 comes out to be about 27 feet per second squared. Okay. And this vector is actually the mass times the normal acceleration. This is my kinetic diagram. This is my free body diagram. So let's go put some forces on our free body diagram. I have weight coming straight down. I'm going to have a normal force. And I'm potentially going to have friction. I don't know for sure whether it's up or down. So what I have to do is assume one direction. Since we're going pretty fast, I'm going to assume I would slide up the curve, up the bank. So I'm going to assume friction is going down the bank. If I get a negative answer based on my equation, I would have assumed incorrectly. Alright, so let's look and see what we got. We got m a sub n horizontal. We know that value. We know the mass and the acceleration. We don't know n. Let me label n now. We don't know the magnitude of n. Okay. And we don't know the magnitude of force of friction. We cannot use mu sub s right here because we don't know that we're at impending motion. Okay, so I'm guessing that would have been a common mistake on this problem, was to use mu sub s times n. We're not told anything about whether it's going to slide or not. In fact, we're told it's not going to slide. We're not trying to find some maximum speed where it would start to slide, so we don't know that we're at impending motion. Okay, so the friction force will just come from the free body diagram. We'll have two unknowns, our friction force and our N. Okay. And based on that, it's usually best to use a coordinate system that's lined up with one of the unknowns. In this case, they'll line up with both, so we just have to do one equation. So let's use, I hope I work this right, coordinate system x going down, y going perpendicular or normal. The thing we'll have to be careful about now is this will have two components. This will have a parallel and a normal component. Alright, but we can do that. We know the angle and we know the magnitude of this total vector here. So if I want to get the friction force, I'll use the x direction and I'll say the force of the friction and plus W, here's my 10 degrees right in here, sine of 10 is equal to mass, which is W over G, times A sub n. Okay, that's this total one. I want just this component, so that's going to be the cosine of 10. I'm sure a lot of people working this problem probably overlooked you needed to get a component. Alright, so I know everything in this equation I can solve for f sub f. So let's write that out. F sub f equals the mass, weight sine 20, move to the other side. So minus 2500 sine 10 plus 2500 over 32.2 times 27 times cosine of 10. Oh, let's hope I got that right. Minus 2500 sine of 10 is going to be a pretty small number. Okay, plus 2500 divided by 32.2 times 27 times cosine 10. Okay, so I get 1630, and it's going to be pounds. Okay, I got a positive number here, so that means I assumed correctly, and so that means the force of friction is down. Part of the problem, real commonly missed. Come on, highlighter. State where the friction force is up or down. So you can either do that with an arrow or just words. So 1630 pounds, and I'll draw it, I'll write it down the incline, down the bank.